All right, so we're going to start talking about trig and review trig a little bit. Most of you, I think, have been already exposed to trig for the most part. So, so this will be a pretty brief kind of review of trig over the next several sections, but we will be using trig throughout the remainder of the course. So there are other things that we'll be using trig for besides just its own, I guess, study of itself. So let's get started. So you may recall, if theta is one of the two non-90 degree angles of a right triangle, then it's formed by the hypotenuse of the right triangle and another side called the adjacent side. The remaining side is called the side opposite of theta. So if you've got some kind of right triangle here, and maybe this is theta, then we would call this the side adjacent to theta. We would call this the side opposite of theta, and we would call this side, of course, the hypotenuse, right? The hypotenuse is the side opposite of the 90-degree angle. So using this convention, we can define the 6 trigonometric functions of the angle theta as follows. We can say sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. Now there are 3 other trig functions that they're not quite as common, I think, but anyway, we do use them still, and you'll see them in calculus for sure. So so you have the reciprocal functions as well, which are these ones. So for sine, the reciprocal function is cosecant. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. Now, you may wonder why sine and cosine are not reciprocals instead of sine and cosecant, right? It's kind of weird. But the reason for the sine and cosine, the secant and cosecant, the tangent and cotangent, is because of cofunction identities, which you've probably seen in the past, and we'll review them again as we go through this stuff. But for now, just suffice it to say that the cofunctions are not necessarily the reciprocals of the original functions, right? Cosine is not the reciprocal of sine. Cosecant is the reciprocal of sine. Of course, with tangent and cotangent, that is true, though, that the cofunction is the reciprocal of the original function. But the way that I remember trig functions, even to this day, even after all these years of doing math and teaching trig and all this stuff, the way that I remember this is Sohcahtoa. Sohcahtoa, it stands for sine, opposite, hypotenuse, right? So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, right? That's how I remember these. So it's a useful mnemonic device to help you remember this stuff. Anyway, let's just practice a little bit. So let's say that triangle ABC is a right triangle. A is 3, B is 4, and C is 5. And first of all, to help us remember, because this is a convention that we're going to use when we deal with trig, or just triangles in general, the angles are given uppercase letters, and the right angle is almost always C, right? So we could call this thing triangle ABC. The sides are given lowercase letters, and the side opposite of its corresponding angle is given the same letter, but in lowercase. So in other words, this angle A, the side opposite is this side right here, so it would be lowercase a. And this side would be lowercase c, and this side would be lowercase b. Now in this case, we're told that a is 3, right? A is 3, b is 4, and c is 5. I don't know why I wrote 3 below the a, but there you go. So with that in mind now, let's figure out all kinds of stuff, right? Sine A. So sine A would be opposite over, opposite over hypotenuse, right? So A over C, 3/5. So sine A is 3/5. Sine B, opposite over hypotenuse, that would be B over C, that would be 4/5, right? Cosine A is adjacent over hypotenuse, so that would be B over C, that's 4/5. Well, that's kind of interesting, right? So sine B and cosine A are the same thing. Well, that's the cofunction identity, right? that's because B and A are complementary angles, right? They add up to be 90 degrees. We know this because the angles of the triangle add up to 180 degrees, but 90 of them are already accounted for with angle C. So A and B add up to be 90 degrees, so they're complements of one another, right? So that's why sine B is the same as cosine A. Tangent A is opposite over adjacent. That's A over B, that would be 3/4 in this case. And that's how the trig functions work, right? That's their definition. Here's another example. Number 2 says, if theta is acute and sine theta equals 2/5, find the other 5 trigonometric functions of theta. So I'm going to start off by drawing a picture. So we've got a little right triangle. Theta is that angle right there. It's an acute angle. And we're told that sine theta is 2/5, so that's opposite over hypotenuse, right? Now we're supposed to find the other 5 trig functions. We could definitely get cosecant right off the bat, right? Cosecant's just 5/2, right? It's just the reciprocal of sine. But to get the other 4, we would need to solve for this remaining side, which we can do using Pythagorean Theorem, right? It's not a big deal. We can say x squared plus y squared equals r squared, or a squared plus b squared equals c squared, however you want to think about it. So x squared plus 4 equals 25. That means x squared is 21. And that means that x is plus or minus square root of 21. Now, remember, when you take the square root of both sides of an equation to solve that equation, you have to have the plus or minus sign, right? That's why I have this plus or minus sign here. Now, because both of these numbers are solutions to this equation from the previous step, right? They both work. We have to decide which one we're going to use, the positive version or the negative version. If theta is acute, then we're going to be using the positive version, okay? Later on, we'll talk about, what happens when theta is not acute. Not that you've never seen this before, right? Because you've all taken trig. But if theta is not acute, then we have a little bit of deciding to do here. So we'll talk. So we'll review that a little bit. But anyway, so now we know that x is square root of 21. And given that information, we can get all the other 5 trig functions. I mean, we were told that sine theta is 2/5. But now we can also get cosine theta. Cosine theta is going to be root 21 over 5. And we can get tangent theta. We know that tangent theta is going to be 2 over root 21. You can, if you want to, you can rationalize that. It doesn't really matter to me. I think that the answers that I give in this section are all rationalized. So to rationalize this, we would multiply by root 21 over root 21, right? We would get 2 root 21 over 21. So, so that would be the rationalized version. But really, either of these is fine with me. So there's 3 of them, and then the other 3, cosecant theta is 5/2. Secant theta is 5 over root 21, or if you want to rationalize it, would be 5 root 21 over 21. And then cotangent theta is going to be root 21 over 2. Okay, so that's it for number 2. Hopefully this is all kind of ringing a bell. Not new information for you. By the way, in case you couldn't tell, I changed locations of where I'm recording these videos. Anyway, okay. So these right triangle definitions that we give for the trig functions, they only work when theta is acute. We'd like to extend the definition so that theta can be any angle that we like. And the way we do that typically is with the unit circle. So let C be a circle centered at 0, 0 with radius r. And let xy be a point on the circle. Let theta be the angle formed by the positive x-axis and the ray going from 0, 0 to the point xy. Ooh, okay, so let's draw a picture. First of all, the circle is centered at 0, 0. Right, so this is going to be the center of my circle, and it's going to have radius r, so it's maybe going to look, I don't know, something like this. Don't make fun of my circles. No, you can make fun of my circles, I don't care. So just pretend that's a circle. But there you go, we've got a circle, and the radius of the circle is r. XY is just supposed to be some arbitrary point on the circle, and r is that distance, right? That radius. Theta is supposed to be the angle. So theta is the angle formed. That's this little ray right here, and the ray from 0, 0 to xy. That's that ray right there. So this is theta. Okay. So that's what this definition is saying. So now we can give the definitions of the 6 trig functions in terms of x sine theta is going to be x over r, tangent theta is going to be y over x, and so forth for the other 6. One thing to note here is that if theta happens to be in quadrant 1, then these definitions coincide, right? So just to draw a quick sketch of that, you know, we've got this circle, theta is in quadrant 1, xy is something like this, right? This is the picture that we have going on. So you can make a little right triangle out of this just by dropping a little perpendicular line. And this distance right here is y, and this distance right here would have to be x, since this is the point xy, right? So you know you went over x and up y to get to that point. And so then if you just use the right triangle definitions, you get sine theta is opposite over hypotenuse, y over r. Okay? Cosine theta is adjacent over hypotenuse, that's x over r, right? Tangent theta is opposite over adjacent, that's y over x, okay? And so forth. So, so when theta is in quadrant 1, these definitions coincide exactly with the Sohcahtoa that we talked about on the previous page. But what's nice about thinking about this in terms of circles, so thinking about these trig functions as circular functions, is that they allow us to define these trig functions for any angle theta, right? Not just acute angles, but any angle. Something to point out is that positive angles are going to be measured counterclockwise from the positive x-axis, right? So when we measure an angle, we go in a counterclockwise direction. Okay, if we move in a clockwise direction, that's legal. It's just that we're going to call those negative angles, right? So negative angles are measured clockwise from the positive x-axis. Let's practice with this definition a little bit. So number 3 says, let theta be the angle formed by the positive x-axis and the ray from 0, 0 to the given point. Find the values of secant theta and tangent theta. Okay. So first of all, we've got the point 2, 3. For me, it's helpful to draw a picture. So we've got some circle or whatever. And we've got the point 2, 3, so it's maybe right there. And theta is the angle formed by the positive x-axis and the ray from 0, 0 to this point, right? So there's theta. So we want to find the values of secant theta and tangent theta. Well, secant theta is r over x by definition, right? We don't know what r is yet. We know that x is 2, but we don't know r. Fortunately, we can use Pythagorean Theorem to figure out what r is, right? We can say x squared plus y squared equals r squared. So in other words, 2 squared plus 3 squared is r squared. 4 plus 9 is r squared. So r squared is 13. That means r is plus or minus root 13. Now, because r is a distance, we always take r to be the positive version of the number. Okay, so we're always going to choose positive values for r. That's not necessarily true of x and y. Okay, but for r, we're going to always choose positive values. So r is root 13. So with that in mind, then we can say, all right, secant theta is r over x. That's going to be root 13 over 2. Tangent theta is y over x. So that's going to be 3 over 2. And that's that. Let's see if we can do part B. So we've got the point 3, negative 1. Oh, my circles keep getting worse and worse. Anyway, 3, negative 1. So maybe, right there or something. 3, negative 1. Okay, and theta is supposed to be the angle formed by the positive x-axis and the ray from 0, 0 to that point. But remember, theta, we're going to measure in this counterclockwise direction. So there's theta right there. Okay, so it's this really obtuse angle. Okay, so tangent theta, well, actually, maybe we should figure out what r is first, right? So again, we can figure out what r is just based on right triangles, right? So this is really a right triangle right here. And we know that x is 3. We know that y is negative 1, but the distance from here to here is just a positive 1, right? And so we can solve for r. We can say x squared plus y squared equals r squared. Doesn't really matter if you use the positive or negative because you're going to be squaring it, so you're going to get a positive value anyway. 9 plus 1 is r squared, so r is root 10. Okay, so this is root 10. So again, we can get secant theta and tangent theta, right? Secant theta is r, it's r over x. Tangent theta is y over x, right? So negative 1 over 3. Okay, and that's that. So that's how this definition works. Oh, we've got one more. Do we really need to do one more? Well, let's work it out. I'm not even going to draw a picture this time because I think I've got the idea, right? This is x, this is y. To get r, I'm just going to say x squared plus y squared equals r squared, right? 25 plus 144 is r squared. That means r squared is 169. So r is going to be 13. Okay. So then we can get secant theta is x over r, and tangent theta is y over x. Well, so that's going to be a positive 12/5, right? So there we go. Here's more practice. It says given that given that sine t equals 1/3 and cosine t is less than 0, in other words, cosine t is negative, find cosine t and tangent t. Okay. So sine t is 1/3, but cosine t is less than 0. That's interesting. When I try to draw this picture, so since cosine t is negative, remember that cosine t is x over r, right? And r is always a positive number. So the only way that cosine t is going to be negative is if x is negative. Now, where does that happen? That happens over here, right? X is negative over here. That happens in quadrants 2 and 3. So given this, we know that t must be in either quadrant 2 or quadrant 3. Now, how do we decide which? Well, look at the other information we have. We know that sine t is 1/3. So sine t is a positive value. Well, sine t is y over r. Again, r is always positive. So the only way that sine t is going to be a positive number is if y is a positive number. Well, where does that happen? That happens up here, right? So y is positive up here. So that's in quadrants 1 and 2. So we need cosine to be negative and sine to be positive. That means we either need t to be in quadrant 2 or quadrant 3, or we need t to be in quadrant 1 or quadrant 2. The overlap happens in quadrant 2, right? So that tells us that t must be in quadrant 2. Okay, so this is kind of the picture that we have going on. We know that sine t is 1/3. So what I'm going to do is going to draw a little right triangle here, and I'm going to label this as sine t is y over r. So I know that this y coordinate is 1, and that r is 3. Okay, so this is what's going on. I need to figure out what this x coordinate is, right, in order to figure out what cosine t and what tangent t are. So, and maybe I should just label it with an x, right? So we can use Pythagorean Theorem for that. We can say x squared plus y squared equals r squared. Now, when I take the square root, I need a plus or minus sign, right? Plus or minus, the square root of 8 is the same as 2 root 2, okay, if you simplify it. So x is plus or minus 2 root 2. Now, this is where we have to decide which sign we're going to use, the positive version or the negative version. Well, since we're over here in quadrant 2, x should be negative, right? X should be negative in this quadrant. So we're going to take the negative version in this case because x is in quadrant 2. So x is really negative 2 root 2. So now we can give our answers cosine t and tangent t. Right? Cosine t is x over r, and tangent t is y over x. You can simplify it. You can rationalize that if you want. So you could multiply by root 2 over root 2. If you do that, we're going to get, first of all, pull the negative sign out in front, root 2 over 2 times 2, right? Because root 2 times root 2 is 2, and then you have this other 2 that comes along for the right, so it's 2 times 2. That's going to be negative root 2 over 4. So there you go, cosine t and tangent t. The main takeaway on this is that you cannot always just take the positive square root. Sometimes it needs to be the negative square root, right? So my advice would be draw a picture, figure out if the variable you're solving for needs to be positive or negative, and then make sure you make the correct choice. On a test or a quiz, I would need to see this justification, okay? Even if the answer is positive. If you just give me the positive answer, but you don't show me why it should be positive, then I'll probably mark you down a little bit for that. So I need to see a picture, you know, and I need to see you actually making a choice here that I'm going to take the negative version. Let's do another one. So number 5 says, given that cosine theta is negative 3/5 and that theta is in quadrant 3, find tangent theta. Okay. So this time we're told right away that theta is in quadrant 3. I'm not going to bother drawing the circle anymore. I know that theta is here in quadrant 3. If I make a little right triangle out of this, I know that cosine theta is negative 3/5. Cosine theta is x over r. So x is negative 3, r is positive 5. Remember, r is always positive. In order to find tangent theta is y over x. So I need to figure out what y is. So let's see. x squared plus y squared equals r squared. 9 plus y squared is 25. Y squared equals 16. Y is plus or minus 4. But which one? Should it be positive 4 or negative 4? And the answer is it should be negative 4, right? Because theta is in quadrant 3. So y is negative, right? You're below the x-axis. So y is a negative number in this case. So y should be negative 4. Okay? That means that tangent theta is y over x. So tangent theta is 4/3. Okay? So that's that one. So hopefully none of this is new information. Hopefully this is helping you sort of recall things that you already knew from the past. One more thing that I want to say about trig functions is that, so we can calculate trig functions when a point on a circle is given, but what if we're just given the angle itself? Like how do you calculate sine of 60 degrees, right? Just off the top of your head. Well, the answer is you can't really. I mean, you can memorize a bunch of values, but actually deriving what sine of 60 degrees is from scratch is something of an involved process. And it's not, with 60 degrees, actually, we can do it with 60 degrees, but with something like, 81 degrees, it would be much more difficult. So, so I want to take you through some things that maybe you kind of learned, but never fully pieced together. I don't know, maybe you did, but one thing that may be confusing to you from trig in the past that you've seen is that you may think that the value of sine of 60 degrees depends on the circle that you use, especially given what we just talked about using using circles to figure out what trig function values are. But it might be surprising to you that actually it doesn't matter at all. If theta is fixed, then so are the other angles of the right triangle. So if one side grows, the other two sides have to grow with it. And so that means that the ratios of each of the sides to one another remains fixed, regardless of how big the circle is that you're using, right? The ratio of the sides is still going to stay constant as long as theta stays constant. So to compute what sine of 60 degrees is, it doesn't matter if the radius of the circle that I use in my calculation has length 1 or 2.5 or 57. It doesn't matter what the radius of the circle is. I'm going to get the same answer in every single case for sine of 60 degrees. Now, since trig function values are independent of the circle used, we might as well make our work as easy as possible by using the unit circle. Okay, so the unit circle is centered at 0, 0, just like the circles that we've seen so far, but it has radius 1, and that's what makes it a unit circle, right? It has radius 1. What's nice about the unit circle is that since r equals 1, sine theta is just y and cosine theta is just x, right? Because remember, the definitions that we had for sine theta was y over r, but if r is just 1, then sine theta is just y, and similarly with cosine theta. What that means is that if you're looking at a point on the unit circle, then the x-coordinate is the value of cosine of the angle corresponding to that point. And the y-coordinate is the value of sine of the angle corresponding to that point. So this is cosine theta and this is sine theta, right? So if 1/2 comma root 3 over 2 is on the unit circle, then sine theta is root 3 over 2, and cosine theta is 1/2. So what we typically do is there are certain values that fall on the unit circle that we just memorize. Okay, we just memorize them. And you probably did a fair bit of memorization in your trig classes. But you should memorize these particular angles and the points that correspond to them. Because what this allows us to do is it allows us to say stuff like sine of 120 degrees is root 3 over 2. Or cosine of 210 degrees is negative root 3 over 2, right? So that's how we use the unit circle to determine values of sine and cosine. But these numbers themselves, they're just memorized, right? You just have to memorize them however you do that. You may be curious if you've never seen radians before. You may be curious about, like, what is this pi over 4, pi over 6, pi over 3? What are they doing? Well, we're going to talk about radians in the future. Do we talk about them here? Yes, we're going to talk about radians on the next page, as a matter of fact. But radians are another way to measure angles, right? So we measure angles in degrees. We've been using degrees so far, but we can also measure angles in radians. So we'll talk about what that means. But 30 degrees is the same thing as pi over 6 radians. 45 degrees is the same thing as pi over 4 radians, and so forth. Anyway, moral of the story is you should memorize the unit circle if you haven't done so already. That may seem a little bit daunting, but let me just say this. There's a lot of symmetry going on with the unit circle. Like, you'll notice that these points here in quadrant 2 are the same as these points here in quadrant 1, except their x coordinates are negative. Same thing with quadrant 1 and 4. They're the same points except that the y coordinates are negative. And in quadrant 3, they're the same points except both the coordinates are negative. So it's not like there's a ton of stuff to memorize for each quadrant. Pretty much once you've got quadrant 1 memorized, you've got the rest of the quadrants memorized. How do you remember quadrant 1? There are a whole bunch of ways to memorize it. You probably have a system for remembering this stuff that you like really well. As far as the angles are concerned, I just have 30, 45, and 60 memorized, and it's obvious the order that they should go in, right? Because remember, theta is the angle between the positive x-axis and this ray, right? So this is clearly the smallest of the angles. This is the medium angle, I guess, and this is the largest one. As far as the coordinates themselves, I know that this point is going to have the largest of the x values. This point is going to have the medium x value, and this point is going to have the smallest of the x values. So they go 3, 2, 1, right? But with square roots around them, root 3, root 2, root 1. Root 1 is the same thing as 1, but it's root 3, root 2, root 1. And then the y coordinates do just the opposite, because this point has the largest y value. It should, right? And this should have the medium y value, this should have the small y value. So they go root 3, root 2, root 1 in the opposite direction. Anyway, it's not terrible to memorize if you just stare at it for a little while, but you should memorize it. Let's talk about radians real quick. Okay, so to understand radian measure, recall that a circle with radius r has circumference 2 pi r, right? The circumference of a circle is 2 pi r. Now, in the case of the unit circle, the circumference is just going to be 2 pi, because r on the unit circle, r equals 1. Around the entire circumference of the circle. If we only go halfway around the circle, then we've gone pi units. Obviously, that corresponds to 180 degrees. So pi radians is equal to 180 degrees. And similarly, every angle has an associated arc length on the unit circle, and that arc length, that associated arc length, is called its radian measure. So to convert between the radian system, the degree system, we use the fact that 180 degrees is equal to pi radians. Okay, so let's practice. Let's go from degrees to radians, negative 45 degrees. I'm just going to do this the way that you would do this in like a physics or a chemistry class or something. I'm going to call this negative 45 over 1, and then I'm going to multiply by something in the denominator to clear the degrees, right? So in this case, I'm going to put my 180 degrees down here. So I want to get rid of degrees, and I want to keep radians. So I'm going to put radians up here in the numerator, right? So this way I'm going to be canceling the degrees and keeping the radians, right? Which is what I want to do. Anyway, you can work this out. 45 over 180 will simplify quite a bit, by at least 5. No, by 9, actually. 45 out of 180 is 1/4. Oh, wow. So actually 45 itself goes into 180. So this is going to be negative pi. Oh, of course, I should have known that. I did know that. I just got too caught up in performing the actual calculation, because 45 degrees is the same as pi over 4 radians. When we don't write anything after the measurement, it's assumed to be radians, okay? There are reasons for that. Radians are really the same thing as just real numbers, which is why you don't have to write a unit of measurement after them. But I don't want to get into all that. You can review your trig notes or whatever from whenever you took trig. Anyway, part B would be the same, right? We're going to multiply by pi over 180 to clear the degrees. And 240 over 180 is the same as 4/3. So this is going to be 4 pi over 3. To convert from radians to degrees, of course, we do just the opposite. We're starting with radians here, and we want to get rid of the radians. So we put pi radians in the denominator, and we keep the degrees in the numerator so that we're keeping degrees. The pi's cancel, which is nice. 180 divided by 2 is 90, and 90 times 3 would be 270. So this is 270 degrees. For 3, this is not 3 degrees, right? It's just 3, which means it's 3 radians. And so to convert this to degrees, we're going to put radians in the denominator, and we're going to put degrees in the numerator. This time, no pi's cancel or anything like that. But we get 540 over pi degrees. If you want a decimal approximation, of course, you can say 540 divided by pi is approximately, that's approximately 171.9 degrees. Okay, so that's that. So that's how we go back and forth between degrees and radians. And now let's practice using the unit circle to evaluate trig function values. So sine 120 degrees, for example, you would find 120 degrees on the unit circle. Remember that sine is the y coordinate of the point that corresponds to that angle. So in this case, √3 over 2. Tangent 330 degrees. 330 degrees is right here. Tangent is y over 2. So that's -1 over √3. Or if you prefer the rationalized version, then it would be -√3 over 3. Either one of these is fine. Okay, so there's tangent 330 degrees. We can do the same thing with the radian measure. I'll just give you one example, and then I'll let you work on, I kind of went in the wrong order, but whatever. I'll do part B for you, and then I'll let you work on part C and part E on your own. But part B, cosine 5 pi over 4. So we find 5 pi over 4 on the is right there. Cosine is the x coordinate, so that would be -√2 over 2. Okay. Before I kind of let you go off on your own, the sooner you can get the unit circle in your head, the better, right? So that instead of having to flip back to having, one of the ways that you can do this is by thinking about reference angles. I'm not going to get into all the gory details there. If reference angles is a completely foreign concept to you, then you might need to go back and review some trig. You might need to send me an email or something and say, hey, can you explain reference angles to me? But the idea is that the angles in all of the quadrants of the unit circle correspond back to angles in quadrant 1. So if you can find the referencing, so like in part B, for example, I know that 5 is just pi over 4. Maybe it's going to be off by a sign. So the way that I do this is I think, well, cosine 5 pi over 4 is really the same thing as cosine pi over 4. But to figure out what the sign is, I just need to figure out what quadrant 5 pi over 4 is in. So I know that I would be past 180 degrees, and I would be somewhere here in quadrant 3. So 5 pi over 4 I know is in quadrant 3. And so cosine is going to be negative there because x is negative in quadrant 3. So cosine 5 pi over 4 is just the negative version of whatever cosine of pi over 4 is in quadrant 1. Cosine pi over 4 is now quadrant 1 you do have to measure. So cosine pi over 4 I know just because I've memorized pi over 4 is negative root 2 over 2. Anyway, if this is unfamiliar to you, again, send me an email. I'll try to explain it in more detail, or better yet, right? Attend the Zoom meeting so that I can explain this to you during the Zoom meeting. Okay, but I'm going to let you loose and see if you can do the other ones. So see if you can do parts C and E. Part F we'll talk about together. Okay, go ahead and give the video a pause. Okay, here are my solutions. I'm going to do this without looking at the unit circle. Sine negative pi over 3. I know that negative angles are measured in a counterclockwise direction, so negative pi over 3. Sine of negative pi over 3 should have the same y coordinate as sine of positive pi over 3, except it's going to be negative, right? So really, if I think about what sine of pi over 3 is, sine of pi over 3, that would correspond to 60 degrees, by the way. But sine pi over 3 is going to have the largest possible y coordinate, right? So the y coordinate I know is going to be root 3 over 2. The x coordinate, of course, is going to be 1/2, but that doesn't really matter in this case since we're trying to find sine. So sine of pi over 3 is root 3 over 2. That means sine of negative pi over 3 should be negative root 3 over 2. Okay. Secant 2 pi over 3. 2 pi over 3. It's more than pi over 3, but less than 3 pi over 3, right? It's somewhere in here in quadrant 2. In fact, to get to 3 pi over 3, I would have to add another pi over 3. So I know that the reference angle for 2 pi over 3, then this is pi over 3. So the reference angle for 2 pi over 3 is pi over 3. So I can think about secant. Well, I know that secant is 1 over cosine, right? It's the reciprocal of cosine. Cosine is just x. It's just the x coordinate. So what would cosine of pi over 3 be? Well, cosine of pi over 3, remember this was pi over 3 over here as well. Cosine pi over 3 would be 1/2. That means secant of pi over 3 is 2. That means secant of 2 pi over 3, being in quadrant 2, would be negative 2. It's negative 2. Now let's think about cosine of 765 degrees. Now this thing is more than 360 degrees. So the way that we figure what this is we just subtract 360 degrees from this number until we get some angle that's less than 360. So I'm going to do 675 minus 360. That's 405. That's still more than 360, so I'm going to subtract 3. So this should be the same thing as cosine of 45 degrees. And cosine of 45 degrees is root 2 over 2. Okay, I just have that memorized. Again, because I have the unit circle memorized, or at least quadrant 1 of the unit circle memorized. So that's how that works. That's how we use the unit circle to find trig functions of angles. Now, what if the angle that you're given is not one of the special angles that falls on the unit circle, so you don't have it memorized. Well, in that case, of course, you're just going to have to use your calculator, right? So for example, cosine 42 degrees. We don't have 42 degrees memorized, so we use our calculator. Make sure your calculator is in the correct mode. Mine is in degree mode currently, and that's good because I want cosine of 42 degrees. So I'm just going to do cosine of 42. Whoops. Let me try that again. Cosine of 42. 0.74-ish. On this one, on the other hand, I need to be in radian mode, so make sure that you get into the correct mode. The way that you do this on your calculator is probably different than the way I do it on mine, but I'm going to put 12 pi, tangent 12 pi over 17. See what I get. That's about negative 1.3, negative 1.32. Okay. So that's that. That's all I have to say in this section. So we'll see you in the next one.